Hello kids, let us learn multiplication of algebraic expressions here. So on this we are going to learn about multiplications of expressions. So multiplication of expressions is same as multiplying integers, and what we extra learn is here we learn how to multiply the literals using exponents concept we use to do that. Basically there are certain rules to multiply two terms, like for example multiplying two single terms. So first what we have to do is step 1, we have to multiply numerals or the numbers, or we can simply call as coefficients, and we have to multiply variables if the variables are of same base. We can add their exponents. This is the things what we have to learn it out. So it depends on the number of terms, the multiplication varies. If there is a parenthesis is given, we have to apply the distributive property and we have to solve it. I'll give a simple example how to multiply two expressions here. So if I give you 2x is to be multiplied and 10x square. These are the two expressions which I brought up. There are single terms in this. So 2x is a term and 10x square is a term. So how to multiply 2x and 10x square is, so 2x times 10x square we can keep in the bracket, or we can keep the into symbol, both are same. As I said, discussed in the first point, we have to multiply the numerals. So let us multiply the numerals. What are the numerals we have is, that are the coefficients 2 and 10. So 2 and 10 will give us 20. So I just multiplied the coefficients, and hereafter we have to multiply the variables. Look at the variables. What is the variable here? X. What is the exponent of first x? It is 1. What is the exponent of second x? So when we are multiplying the variables with same base, we have to add the exponent. So 1 plus 2 is 3. So here we have to write x to the power of 3. This is the multiplication of the two terms 2x and 10x square. Here I brought few practice problems on multiplication of expressions. So all the expressions are single term expressions. So single terms, x times 3x. So how do we do this is x times 3x. So what is a coefficient? If you can see, there is no coefficient here. Only the coefficient here is 3. So we have to write 3. There is no coefficient in the sense 1 will be there automatically. 1 times 3 is 3. And if you can see the variables x and x, so x to the power of 1 times x to the power of 1 will give us x square. So I'm just writing that x square. And then second question, negative 2, which is negative 2, basically negative 2 here, negative 2 a square. So negative 2 times negative 2, negative 2 times negative 2 is 4. And then if you simply multiply minus into minus, which is plus 4 it is. So we can simply write 4. And then look at the variables. If you can see the variables, in the first term we found two variables, a times b. In the second term we found only one variable, which is a square. So variables with same base has to be multiplied. So look at this, these two are the variables, a times a square. So a to the power of 1 times a square. So we can write as a to the power of 3. So using this we can put it up, a to the power of 3. And there is only one variable b remained, so nothing to multiply with, so keep it b as it is. So this is the final answer. Coming to the third practice problem. Look at the coefficients 2 and 3 are there, no? So just simply multiply this coefficient 2 and 3. So 2 times 3 is 6. So I can put 6 here, and let's see the variables y and y square. so as same as a and a square. So the result is y to the power of 3 and only z is left, so keep it as z. That's all. And coming to the next fourth practice problem. So look at the variable coefficients 3 and 4, which is 12 and x square and x. So x to the power of 3, and there are two y variables are there in this. Look at this, y square and then y, so which is y to the power of 3. Next question. So let us multiply the coefficients. 4x to the power of 5 minus x cube y square z minus y square z. If you can see, three terms are multiplied together, even it is two terms or three terms, same process as we multiply three integers, no, the same way. So only one coefficient I found here, so that is to be written in the final answer, and later on we have to check step by step the variables. First I am checking with x, so there are two x variables found in two terms. So x to the power of 5 and x to the power of 3, if I can see that x to the power of 5 times x to the power of 3, so which is x to the power of 8. So I am putting up in the answer x to the power of 8. And if you can see that y terms, and look at this, y square and y square, so which is y square and then y square, y to the power of 4, so we can put it up y to the power of 4. And the z, how many z terms are there? Two are there, z and z, so both are having single power, so z to the power of 1 and z to the power of 1 we can write as z square. So using 3, I'm just putting it up here, z to the power of 2. Now let's talk about sign. So there is negative sign and negative sign, all three are multiplication. Negative times negative is positive, so the result will be positive. Need not to mention the positive sign there. So the answer is 4 x to the power of 8 y to the power of 4 and z square. Let's move to the last practice problem. X to the power of 4 whole square. We already have a rule that, so in exponent, a to the power of m whole to the power of n. So power rule we can call it as. Simply multiply both the powers. That's the answer. So a to the power of m times n. So I'm just applying the logic here in this question. So let's see, x to the power of 4 times 2. So we can write as x to the power of 8. This is the final answer. So this is how we multiply single terms in the algebraic expressions. In the next video, we are going to learn about multiplying an expression which is having two terms and how do we multiply that, and we'll see that.